2.14, logarithmic functions. Here we go.
The average salary for a church pastor across the U.S. increases as the size of the church increases. The graph above shows the average pastor salaries for various church sizes. We can clearly see a pattern in the data, but the models we have used previously are not appropriate for this data. The growth above displays a large rate of change initially, but as the church size increases, we see the rate of change gradually decrease. The data above appears to be logarithmic. Just as we have seen with the other types of functions, linear, quadratic, exponential, many real-world scenarios follow a logarithmic pattern. Outside the salary data in the graph above, logarithmic patterns are found in the way we measure earthquakes, sound, acidity, and many other contexts. As a result, we have a need to create logarithmic models for these types of data.
All right, so a lot of data in the real world is logarithmic, which is the inverse of exponential. All right, exponential. All right, and so a lot of things aren't exponential. They don't grow and grow forever and ever. And so they kind of level off, and that's what logarithmic functions do. All right, so let's keep going. You're doing great.
Logarithmic function models. For a given set of data, if the input values appear to change proportionally over equal length output value intervals, then a logarithmic model is appropriate.
All right, so I'm going to stop there. You probably want to understand this definition. Okay, when we're given a set of tables or something, we need to understand that lingo. All right, so our inputs are proportional, our outputs are linear. All right, keep going.
A logarithmic function model has the form y equals a plus b natural log x, or y equals a plus b log of x, where a and b are constants and b does not equal 0.
All right, fantastic. So we're going to get these problems a lot, especially in a free response on your AP exam. And so this is going to show up a lot. So we have this data set. What are my input values? My x's are the L of x. My x is the input values, and my output values are the L of x. And so it's in this form. L of x is equal to a plus b natural log x in this sense. And we're going to write two equations. So all I'm going to do is substitute these in. And so what's my output value for my first ordered pair? 3. So now I have 3 is equal to a plus b natural log of what? 2. Exactly. And so then I'm going to do it again. And so now what is my all right, so what's my next ordered pair for my output? 7. And so now I have 7 is equal to a plus b natural log of 5. And so that's what part A is asking. And then part B, it says, hey, find the values of A and B. And so on this one, it will be calculator heavy. However, you guys remember system of equations with like the x's and y's and junk? Mm-hmm. And so this is a system of equations, because how many variables do I have? 2. I have 2 unknowns, and I have how many equations? 2. So I have 2 equations, 2 unknowns, and we're going to solve it with a system of equations, just like before. However, this is going to have a natural log. And so this is the way I'm going to personally do it. I'm just going to rewrite them down here. And then what variable could I get rid of the easiest? What variable could I get rid of the easiest? I can get rid of a. And so the way that I personally would do it is I would distribute a negative on this lower one. And so when I add straight down, my a's will cancel. See how that works? And so 7 and then plus negative 3 is how much? Say 4. 4, good. And so then what happens to my a's? They cancel. And so then I'm left with b natural log 5 and then minus b natural log 2. All right, because I don't know what b is yet, so I need to solve for b. Well, what can I do to get b by itself? What could I, starts with an f. I could factor out a b. And so now I'd end up having 4 is equal to b times the quantity natural log 5 minus natural log of 2. So now what's the relationship to solve for b? So right now they're being multiplied, so what do I do now? Divide. And so b is equal to 4 over natural log 5 minus natural log 2. So we're going to actually put that in our calculator. So here we go. And so now we solve for b. And so b is equal to this 4.3654, it looks like. All right. And so now I want to take this right here and solve for a now, because now I solve for b. Now I need to solve for a. So now we're just going to back substitute b in right here. And so how would I solve for a? It would be 7 minus this portion. Does everybody follow me? All right, or 3 minus this portion. It doesn't really matter which one you substitute back in. All right, and so a would equal that. And so I'm going to show you how to do this with it in your calculator, and hopefully we'll see it record or not. I don't know. All right, and so now I'm going to press in a 7, and then minus. Now, this is where I want you to focus on. So if you go up to this portion and you press enter, it copies and pastes it right there for us. Everybody see how we did that? All right, and then all I have to do is type in natural log of 5. It's natural log 5, isn't it? I think so. All right, and so then my a will equal this negative 0.0259. All right, go ahead.
Example number 2. The table above gives the data from the graph at the beginning of the notes, related church size, and average salaries for pastors in the United States. A. Use the regression capabilities of your graphing calculator to find a logarithmic function model for the data above of the form S of P equals A plus B natural log P, where P represents the church size and S is the average pastor's salary in thousands of dollars.
All right, so again, how do we get to our calculator? We go to stat and then what? Edit. All right, then we're going to go stat, edit. All right, so once we get to our list, then we go to what? Stat and then calc, and then we want to go to our linear or our natural log regression. So that's number 9. So then we press enter. And then how do we store? Remember trace?
Alpha trace.
Alpha trace. All right. We're going to store that in there and calculate. So once we have that, now let's go to part B.
On part A, what is the predicted annual salary in thousands of dollars for a pastor whose church size is 500 people?
All right, fantastic. So what do we need to do here? We need to find S of what? S of 500. Now, when we find S of 500 on this one, what are we actually going to do? Go back to our main screen and then get to alpha trace, get what Y1 is, and then of, so put our parentheses, of 500. And so for a congregation of around 500, that pastor is said to make about $94,000. All right. All right.
Okay. Example 3, the most common and preferred method to measure sound intensity levels is in decibels. The sound intensity levels, B, I don't know what that is.
Beta.
Beta, in decimals, having a sound having intensity I in watts per meter squared is modeled by the function beta
Of I.
intensity,
Oh, sure.
okay, equals A plus B log of I. Intensity.
You're great.
Did that keep going?
Yeah.
Where A and B are constants, the sound of noisy traffic has an intensity of I times 10 to the...
That's 1.
Okay, well that's kind of hard. 1 times 10 to the negative 5th watts per meter squared and corresponds to 70 decibels. A loud concert has an intensity of 1 and corresponds to 120 decibels. Use the given data to write 2 equations that can be used to find the values for constants A and B in the expression of beta of I.
All right, beautiful. All right, so what's my inputs? Is it beta or is it I? I is my input. And so I matches our watts per meter squared. All right, and so then what is my input value? Is this my input or is this my input? Is 1 times 10 to the negative 5th my input or is 70 my input? 1 times 10 to the negative 5th is my input. And then this is my output. This is my beta of I. All right, and so we're just going to just substitute it in here. And so then, how do I write that equation? It would be what? 70 is equal to a plus b log of what? 1 times 10 to the negative fifth. All we're taking is our ordered pairs and substituting it in. All right, and we're going to do it again. And so now, what's my next output? 120 is equal to a plus b log of what? 1. All right. And so there are my two equations. So it's very similar to that first example we did. All right. Now let's look at part B. It says find the values of A and B. And so when we find the values of A and B, you could totally do what we did last time. You could get rid of A's. Does everybody follow me? However, this one doesn't actually require a calculator. All right. It's very similar to example or problem number 3 on your homework set. So let's look at it. So what is this base here? Base what? 10. It's a base 10, right? And so how do we solve a log? A to the C is equal to B. And so my A is what? 10. To the power of what gives me 1? 0. Exactly. So 10 to the power of 0 is 1. And so log of 1 is actually 0. And so then, what is A then? Because 0 times B is how much again? 0. And so A is equal to 120. All right, you see how easy that one was? All right, so A is equal to 120. Now let's do it again. So now I'm basically going to take this 120 and I'm going to substitute it in right there. And so now I'd have 70 is equal to A, which is 120. Oops, that error should go there. All right, and then plus B log of 1 times 10 to the negative fifth. Now, 1 times 10 to the negative fifth is 10 to the negative fifth, right? And so again, what's this base? Base what? 10. So it would be 10 to the power of what gives me 10 to the negative fifth. So this is what? Negative 5. And so now I'd end up with 70 is equal to 120 plus B times negative 5. All right. And so then let's solve. So we're going to subtract 120 to get how much? Negative 50. And then I'm going to divide by negative 5. So what does B equal? Not negative 10, but
10.
Just 10. All right, so A here is equal to 120, and B is equal to 10. Now, could we do that with our calculator if we were given that? Yes. However, this one we can solve pretty easily. All right, let's keep going.
The human eardrum can burst when sounds reach an intensity of level of 1 times 10 to the 4th watts per meter squared. According to the model found above, what is the predicted number of decibels required to burst a human eardrum?
All right, fantastic. So we need to come up with a new one. And so what is our B of I equation? So my B of I equation is equal to this A plus B log of I, right? And so B of I would be equal, what's my A? 120 plus, what's my B? 10, and then log of I. And so what am I doing with this 1 times 10 to the 4th? That's my what? That's my input. That's my input. Now I'm looking for my what? My output. So I'm looking for B of 1 times 10 to the 4th power, which is equal to 120 plus 10 log of 10 times 10, or not 10 times, 1 times 10 to the 4th. All right. Well, what is 1 times 10 to the 4th? That's just what? 10 to the 4th. All right. And so again, how do we solve a log? A to the C equals B, right? And so I'd have 10 to the power of what is equal to 10 to the power of 4? This is what? 4. And so then I'd have 4 times 10, which is how much? 40. 40 plus 120 is 160. So I'd end up with 160 decibels. All right. All right. Now let's read the fun fact. I actually really enjoy this one. Read the fun fact. This is good.
All right. Fun fact, The word decibel comes from two pieces. Number one, deci refers to the fact that the level of sound found is multiplied by 10 as part of the formula. Two, Bell references Alexander Graham Bell, the inventor of the telephone, and the person decibels are named after.
That's beautiful. All right, I never knew that. Yeah, there's a good nugget for you. There you go.